and it's a pleasure for me, but it's not the first time for my family, because my family is coming from Sweden 400 years ago. Together with Gustav Adolf, they entered Pommern and they settled down in Stettin, which is now Poland, and they get to Riga, and my grandma, she was born in Riga. She was a German-speaking Russian. She was German, but had a Russian passport, and she was living in St. Petersburg, and after the First World War, she had to come back to Eastern Prussia and coming back to Kiel. It's always Eastern Sea, and currently I like water. I'm still living at water. This is a picture of Starnberg, nearby Munich. It's a beautiful place for living. So, coming back to reality, yesterday we have heard something about Scrub the Hub. Maybe we heard today something about Scrub the Catheter. But it's not true. We hear something about the numbers of catheter-associated infections, something about innovative materials and coatings, the clinical results. We are discussing the risks, adverse effects, resistance development, some meta-analysis, Cochrane reviews, as well as the pharmacoeconomy of catheter coatings, because in summary there are 3 types of catheters on the market with a huge clinical experience. It's still an important topic because this is a review from Dr. Wenzel in the New England Journal of Medicine. He was estimating that about 25,000 deaths are attributed to the use of central venous catheters, and it's much more for patients coming from oncology, especially hemato-oncology, transplantation patients, patients from burn units, as well as pediatric patients. And for instance, I found literature source showing that 89% of bloodstream infections in pediatric oncology might be associated with the use of central venous catheters. It's worse for preterm as well as very preterm babies because of the greater immune immaturity, the immature skin, the higher need for more invasive devices, as well as intravenous feeding. And therefore, we have a 1.6 to 2.7 higher rate of DSI compared to a normal pediatric population, and we have a cutoff for extremely preterm babies. They may have a share of about 10 to 15% of the population, but make more than 50% of the bloodstream infections. This is a cutoff smaller than 1.5 kilogram, and the rate of bloodstream infections caused by catheters is about 5 to 10-fold higher than the normal population. And the NHS also published a work, a review, a survey on 20 university clinics in the UK, that between 20 to 25 of preterm babies develop one or more bloodstream infection. Okay, what is the most important factor to get such an infection? It's a low birth weight, and secondly, the time is the inventing time of catheters, because the median time to develop a catheter-associated infection is not 1 or 2 days, it's between 7 to 9 days. So the longer the catheter stays, the higher the probability of any catheter infection. And we also know very exactly what's coming out after a bloodstream infection. You have a much higher risk of necrotizing enterocolitis, a much higher risk of neurological impairment because of increased duration of intensive care, as well as finally death. The skin is the most important source for getting catheter associated infection. And therefore the colonization of the skin is the biggest, the disinfection of the skin is of most importance. About 70 to 80% of bugs are coming from the skin. About 20%, we heard it yesterday, is coming from the hub. And by bloodstream, there are only 1 or 2% of bacteria which adhere from the blood at the catheter, inducing a catheter-associated infection. We have heard it's possible to scrub the hub, but it's nearly impossible to scrub the catheter. The most important organism colonizing in the first weeks the skin of babies are, of course, staphylococci, followed by Candida. And therefore, staphylococci are the predominant species of bloodstream infections caused, associated with the use of catheters. And we find some Staphylococcus aureus, multi-resistant Staphylococcus aureus, which is not from the skin, but from the skin of the doctors or nurses. We find some gram-negative pathogens and a growing number of Candida albicans. This is a very old but very nice electron microscopy picture of staphylococci adhering to a surface of a catheter. Only some bacteria adhering to such a surface in the body are enough to form such a biofilm after 24 hours. The biofilm consists of an extra polymeric matrix, and the staphylococci are embedded in this matrix. This matrix, so-called slime, is protecting the bacteria from the host immune system as well as therapy by antibiotics. And you have to keep in mind, any foreign body implanted in any human tissue is inducing an immunocompetent inflammatory zone, every foreign body. And if these foreign bodies are colonized by some bacteria, the bacteria are stepping into and developing a biofilm, and some of these bacteria are in a dormancy state, and therefore they exhibit a phenotypic, very high antibiotic resistance, not a genotypic, it's a phenotypic resistance, and therefore it's nearly impossible to prevent such an infection by previously applied antibiotic treatment. We have heard it yesterday by scrub the hub. And it's nearly impossible, if you have an infection, to kill the biofilm by any antibiotic treatment. You have to withdraw the implant material or the catheter. And this phenomenon is very well known. In the 50s, an English group was discovering the phenomenon that the cut-off for any infection is lowered significantly by the presence of any foreign body material. What can we do against it? Yesterday you have heard something about bundling strategies, maximal barrier precautions, removal of unnecessary lines, hand hygiene, chlorhexidine, skin preparation, and so on and so on. And in addition, you can use the chlorhexidine bath, but it has a low priority, and you can use antimicrobial locks as well as antimicrobial catheters. And for the development of any antimicrobial material, you have two general directions. The first is to create killing a biocidal surface, killing bacteria by releasing antibacterial drugs, or to create a surface which is smooth or anti-adhesive, repulsing all the bacteria. The first attempt, the anti-adhesive surface, has a theory for it. It's the low energy theory, and we know that particles do not adhere really if a surface has a very low surface energy, like silicone or Teflon. And therefore the coating of many materials, not only medical devices, also for ships, has been done by hydrophobic surfaces, avoiding biofilm formation. Biofilm formation is also very present in the sea, and maybe this sink of Concordia was not caused by the captain, maybe by the biofilm, and very important for you in Sweden. The Vasa warship, the big Vasa warship, maybe it was not the weight, it was a biofilm. You have to find it out to correct the history. Okay, what has been done, what kind of development has been done in the last 50 years after Elegant Cohn discovered this phenomenon? The industry introduced new polymers like polysulfones, polymethyl methacrylates, and so on. And there have been many attempts to render the surface more hydrophilic. It did not work very well. There was a work in Bonn. They developed the lotus effect, nano structure on the surface for repulsing the bacteria. It did not work in reality. There are some products on the market with hydrogels. I think there is a Swedish company, Kameda, which placed such catheters 20 years ago into the market, but they did not show any antibacterial effect. The same company was introducing pentosaccharide or heparin-coated materials into the market. It's very well known for membranes, but not for catheters. And the most important development is the coating by silver, by antiseptics or antibiotics or combinations of them. So, this is a picture of the attempts for silver antiseptics as well as antibiotics. We have the so-called matrix-bound antibiotics. Antibiotics are embedded in the depth of any material. Examples are the rifampin micronasal catheters. We have the adsorption of antibiotics. These products have been launched into the market 20 years ago, but removed. We have iron-bound antibiotics. These are the rifampin minocycline catheters, and we have the impregnation with chlorhexidine. These are the chlorhexidine catheters by the company Arrow, and we have some attempts to put silver on the surface or into the material of catheters. Silver seems to be ideal. Why? We know from history that Alexander the Great was always drinking his wine from silver bottles or silver cups. Unfortunately, I think he was dying very early, in the age of 37, maybe induced by infection. But nevertheless, we know that silver is very active, but silver not as a metal, it's a silver plus, it's a silver ion. The silver ion is able to disrupt the membrane of bacteria, to interact with the DNA and to interact with the protein synthesis, being bactericidal at higher concentration. So, and my question is, why don't we use silver-coated devices in our clinical practice? Because silver is cheap. You don't have such regulatory hurdles for getting any CE certification or regulation act. And what is the reason behind we don't have these products with broad range in the market? It's the efficacy. We have done 13 years ago a very simple experiment in Cologne, in our Institute of Microbiology. I was working for 8 years, and we were adding to broth only some albumin, and we could could show that the MIC was rising about a factor of 10, and if we also put some chloride ions to the solution, the MIC was also rising by a factor of 5 or 10. So it means albumin and chloride, which are major constituents in blood and biological fluids, are diminishing the activity of silver by 19 to 99%. If you are getting some in vitro data of new silver devices, which are very nice, they have always been done in broth, never with albumin or chloride. And therefore, the meta-analysis, the health technology assessments and reviews in general for silver-coated devices are not positive. You see a lot of studies have been done, so positive studies which have been done, for instance, by Boswald nearly 20 years ago, where there's a very low number of patients, and the studies with negative outcome have been done with big patient cohorts, and therefore there's no recommendation for using silver-coated catheters, unfortunately. Okay, what to do? In the market is, since more than 40 years, are local drug delivery devices for surgery. One example is collagen impregnated by gentamicin. It's a device for it's a local treatment of infections of the bone and the connecting tissue. And it's a drug delivery system delivering gentamicin over days and weeks. And the second product is are the chains of polymeric networks releasing gentamicin, and for the same use. And the physical principle is that gentamicin is completely embedded into the polymer, and after implantation the drug will be released in a sustained manner, creating very high surface concentrations, very high local concentrations, killing in the neighborhood of the device all bacteria, which is not possible by any systemic application. These concentrations are about 100 to 1,000-fold higher compared to any systemic application. That's the reason why in surgery such devices are being used. Okay, what is the ideal drug delivery system? The ideal drug delivery should be active over the whole embedding time and within the therapeutic window. It makes no sense to have a coating system which induces a very high burst effect, and afterwards we have nothing, and the catheter or the device is still vulnerable. Therefore, we have three general types of coatings, and two of them are of most important. It's a coating. The coating of a device by a very thin layer, externally as well as internally. This has been done for the chlorhexidine catheters and as well as rifampin minocycline catheters. And the impregnation of the whole matrix, it has been done for the rifampin micronesol catheters, which have been investigated in the premature baby trial. And it's very difficult to, from the industrial standpoint of view, to make a catheter with a coating if the catheter has a diameter of 1 millimeter, 1 French. So it's not possible to get a coating for the very thin catheters. Therefore, the reason that only the very fine catheters, coated catheters, are matrix-loaded catheters with rifampin micronesol. It's very important that such catheters exhibit a very high, a very long activity over time. You will see the release rates in the steady state, and therefore, after 2 or 3 weeks, you still have a significant activity against staphylococci. This has been withdrawn from a clinical diaphragm from the first clinical trial, and you have a look to the inhibition diameter after 20 or 30 days of indwelling time, and we still have a significant antimicrobial power. Okay, how to perform clinical trials. The main objective of any clinical trial with catheters is the reduction of rate of colonization. The second parameter is the reduction of bloodstream infection. Bloodstream infection is much more important because of the clinical standpoint of view, but sometimes you have, in case of adult patients, a relatively low bloodstream infection rates. Therefore, this is a primary endpoint. Eggemann and Pité from Switzerland published a very nice work. It's not. It's still a very nice work, and on cumulative data on control catheters, on chlorhexidine catheters, as well as rifampin-loaded catheters, and they could show that if you have a colonization rate of about 30% of catheters, you will have a BSI of about 3 to 5%, and if you reduce the rate of colonization by 50%, about, you also get a 50% reduction of BSI, and if you reduce the colonization rate much more, the rate of BSI will be much lower. So it's very logical, no bacteria, no bloodstream infection. Okay, coming back to the rifampin micron-azole catheter, it's very important that I think there are 10, 15 products on the market in general which claim any antimicrobial efficacy. It's very important to state out that you need clinical data, and it's more important, not only one study, you need much more studies. Because sometimes you are getting study data which are positive, and you need a big number of patients to clearly stating out clinical efficacy. And for instance, the rifampin micron-azole treated catheter could show in the first study 86% reduction of colonization, 76% reduction of infection rate, 100% reduction of BSI rate, and the cumulative data on nearly 900 patients could show that the zero BSI rate could reduce down to low. It's by accident, maybe in the big study, which has been performed in England at the NIH. It's a PREVAIL trial. It's a trial on 858 babies in 18 university hospitals in England, paid by the NHS, finished in January this year, and we are waiting on the results every week. And maybe we are getting some bloodstream infections, but the pilot study performed from Dr. Flemmer 2 years ago in Munich could clearly show that we have no cases of sepsis, some cases of infection and some colonization, but in summary, a significant reduction of any infectious event. Now, hopefully, the results of the NHS trial are positive. I think we are getting the results this year. Okay, coming to 2 slides of meta-analysis. In general, the meta-analysis of this colleague could not show for the chlorhexidine catheters a benefit, could not show a benefit in terms of colonization for silver-coated catheters. It could show a benefit for minocycline rifampin catheters, and could show it for micron-azole rifampin catheters. Next point, Candida colonization. We have to state out that in this study, the risk of Candida colonization was significantly increased by the use of minocycline rifampin catheters, which is not the case for silver and chlorhexidine catheters, and of course not for the micron-azole catheters, in which micron-azole is the antistaphylococcal active antifungal drug. What is Cochrane telling us? Cochrane is telling us, okay, the data are fine, and we think in terms of catheter colonization, rifampin impregnation appeared to be superior to chlorhexidine and superior to silver and heparin coating. So it's fine. And the question is, what is it cost cutting? What can we do with the cost? Because any innovation costs money, and can we bring the money back? And the Americans have a clear message. The Americans say it's only possible to save money if you have a 75 risk reduction and a very high rate of bloodstream infection. If you have it, you can save money. You can save money until up to $200 per antimicrobial central venous catheters for adult patients. I don't know the number for babies, for preterm babies, but I think it's similar. Because the costs of sepsis is between 10,000 and 20,000 US dollars. It's similar to the costs of adult patients. What is about resistance development? If you place any topical antimicrobial treatment, it's the first questions coming from internal medicine or microbiology, and you are using rifampin, you are using chlorhexidine, what is going on over time? And there has been done a lot of work investigating, I think, nearly 1 million catheter days with chlorhexidine as well as rifampin-coated catheters, and nobody could find a hind up to date for resistance development. Be cautious, but up to date, the authors did not find any hind. That the local delivery of antimicrobials, you have to keep in mind that an antimicrobial device is not inducing any systemic level of drugs. You only have a local level of drugs. Because only micrograms are released compared to grams of antibiotics applicated systematically. No systemic application of the drug, only local and up-to-date. Luckily, no hint for any resistance development. But what we have sometimes is the phenomenon that chlorhexidine, for instance, is inducing anaphylactic shocks. 15 years ago, the chlorhexidine catheters have been removed from the Japanese market, and in Germany the B-Farm is clearly observing the 100 cases of anaphylaxia every year induced by chlorhexidine. Okay, coming to the end, makes it sense to use antimicrobial catheters for adult patients as well as for NICU patients. Coming back to Cochrane, what is Cochrane telling us? Cochrane is telling us while the overall body of evidence still allows recommendations in favor of use in practice, there should be a great caution in recommending the use of antimicrobial catheters across all settings. This is clear. And therefore, this is my last slide, the guidelines for using antimicrobial catheters, rifampin and chlorhexidine catheters, are subgroups of patients showing a higher serum BSI rate, patients with a long indwelling time, as well, of course, neonatal ICUs, immunocompromised patients with enteral nutrition, and as well as hemato-oncological patients, dialysis patients, burns.